Greetings, my name is Edwin Joseph, VETS11. Today we are going to talk about our project assignment for subject digital electronics. So basically, this practical assignment we required to create a mini project, which is as a connection with the subject digital electronics. So our topic we are taking is a digital clock circuit. So my group consists of myself, Edwin Joseph, Zola Aziq Adiemi, Mohammad Zakwan, and Mohammad Azim Razali. Okay, so for the background of this project, actually is we are using a 1 Hz of pulse is generated with a second counter count. That means the frequency of it generated will be as 1 Hz to make the second counter count, which is 1, 2, 3. The frequency of it is 1 Hz. So whenever the second counter counts to 60, immediately it resets to 0 while the minute counter counts 1. So basically, when it detects 59, 60 will be 00. The minute, which is the minute display, display is 1. Basically, 60 seconds equals to 1 minute. And then when the minute of the 60 part they will show is 00, and the next one, the hour display, it was set to 1. So basically, it's hour 1. So maybe it may be different things. Basically, it is reset. Okay, so the problem is like for this digital clock, it's like a lot of the time is taken to reach the time from the classic analog clock, which is you're using arrows. Arrows, they don't display the numbers; they only show from number 1 to 12, and they don't show the second time. So basically, how we need to read the time for the analog clock. We see the position of the needle, and from there we see where the position maybe is number 4 and number 3. We need to see the size of it also. For the hour one, we use the short arrow, and the other one is for the minute. So basically, we need to look at all the elements to determine the time. Whereas for this digital, the number will immediately pop up, and it is more accurate because it will display the second also. For analog, they show because there is a constant going needle, one needle going around the clock. And what is the second? So 1 second will move around in the clockwise motion. So basically, it's quite the time taken for us to reach the classic analog clock. Okay, so the next slide will be discussed by my friend. So that's all from me. Thank you.
Assalamualaikum warahmatullahi wabarakatuh. My name is Mohammad Azim Razali, and today I'm gonna present about the IC74LS94. This IC is a mode 10 decade counter that generates a VCD output code. It consists of 4 master-slave JK flip-flop, which is internally connected to provide mode 2 counter, and mode 5 counter. This IC also has an independent toggle JK flip-flop by CLKA, and the other 3 are driven by the CLKB. This is the picture that I use in this presentation. The basic way to use this IC. This is the truth table of the IC. Let me show you the simple way to use the IC. As you can see, we use the voltage power supply. As the time begin, the display, the number on display is changing. We also the time taken to the number change is depend on the frequency that we set it. if we change it to 100, the display will gonna be faster. I think that's all from me. Thank you.
Assalamualaikum, my name is Aziq Adiemi bin Putra, and this video for assignment digital electronic mini project. In this assignment, we use two types of IC, which is 74LS47 and 74LS90, and I will explain this IC 74LS47 BCD to 7 segment decoder. So as you can see, this IC connected to this input, 4 inputs A, B, C, D, and actually this input from another IC 74LS90, and the output connected to this 7 segment display. For example, if the input data is 0001, so 7 segment display will show number 1, and then if all the input data is 0, so it will show 0, and if 0010, so the input data is show number 2, and this IC will show from binary number from 0 to 9. And then after we run the simulation, we can get the output, and we can fill the output in this truth table. For example, 000 for the input data, and the 7 segment display will show number 0, and this decoder output is from the 7 segment display. For example, if 7 segment display show number 0, so A, B, C, D, E, F is 1, and then G is 0. If the 7 segment display show number 1, so just BC is 1. BC is 1. So from the truth table, we can do the K-maps. For example, if okay, for K-maps A, so this one is A. Okay, so 1011, 1011, and then 1011, 1011, and then 0111, and the last two number is 11. So from this K-maps, the output or Boolean algebra for A is B bar, D bar plus C plus BD plus A, and you can continue for B, C, and D until G. That's all. Thank you.
Hello, Assalamualaikum. My name is Mohammad Zakwan. Today I will explain about digital clock circuit using a multi-sim. As you all can see, this is our circuit for digital clock, and I will show you in the multi-sim. At first, we have to list down all the property that we have to use, such as 7 segment hex, 7447N, 7447N, 7490, OR gate, switch, power supply VCC, and this is function generator. So after we list all of it, we will connect the circuit like this. VCC, every line is to support the power system. We don't want to make one VCC connect all because we are afraid it will short the circuit. So we make one VCC for one supply. For this 7 segment decimal, we use one VCC. For the IC, we use one VCC, and for the OR gate and the switch, we use one VCC. So I will run it. As you all can see, At here is hour, this is a minute, and this is a second. When I push it for setting up to make it 1 minute, so that means 1 minute 50 seconds. The function of function generator is to make the frequency slow or fast. If I change the frequency, the second will go fast. Also, if I change the amplitude, so you can see if I change the frequency, the counting of the second will be fast. But we want to make it a normal 24 hours or 12 hours. It's equal to 1 minute equal to 60 seconds. So that means we have to use 1 hertz to make it slow back. To make it slow back equal to 60 seconds, and then it will change equal to 1, and so on. So that's all for explaining a digital multi-clock. And for the conclusion, I will explain is to summarize the purpose of mini project is to design the digital clock that display the time digitally in constant to an analog clock, where the time is indicated the position of rotation hand with the helpful counter indicator. A digital clock to display time in hour, minute and second can be constructed. Digital clock is help us to see time more easily than analog clock that we have to count it or we have to watch it more often than digital clock. So that's all for today. Thank you.